Now let's look at continent versus continent. So if two plates are converging and all of the oceanic lithosphere between the two plates has been subducted away, and the continental land masses come into contact and start to collide, then you will get a continent convergent zone. And in this case, it's a little bit different because the two sides are too low density to subduct down into the mantle. And so instead, they just crumple together and they form a big range of mountains, sometimes called a collision zone. And here's the best example that we almost always give in this case, which is India colliding with Asia over here and pushing up the Himalayan mountains. And let's look at the earthquake evidence there. And so we will select our new region here across that boundary like so, and see what pops up here. And what you can see is that there's a lot of earthquakes, and they range over a wide area, starting at the boundary and continuing onto one of the plates. And we typically, in this case, would pick the boundary as being right along here, kind of at the edge of where this happens. And you can see that they do vary a little bit in depth. They're not all as shallow as some of the other types of boundaries, but they don't tend to go to the real deep ones either because it's no longer a subduction zone. So if we look at it in 3D view, and we can lift this up and see that they're all pretty much shallow to moderate depth earthquakes. Back to the browser here. Let's look at the size of these quakes. There's very frequent quakes, but let's look at them here. So ranging up to almost a magnitude 8, and I think you could probably have a magnitude 8 plus earthquake, maybe not a magnitude 9. I don't think we've ever recorded a magnitude 9 quake from one of these types of areas. As far as the depth goes, it ranges from very shallow to moderately deep. 148 kilometers deep is pretty deep, but of course it gets a lot deeper in some of the other types of boundaries. And let's look at the Google Earth version of this here. And what you can see here is that there's really nothing in terms of volcanoes. There's a few scattered minor volcanic areas here that don't seem to have very much to do with the tectonics of that area. They could be hot spots, or they could be just kind of random volcanoes. And let's look at the topography across this boundary through the Himalayan mountains. If we click Show Elevation Profile here, I've got a profile that I made across that boundary. And so you can see India kind of down in this area, and then you get to right at the edge of the Himalayas, and then it goes up very steeply, and then you have a very high plateau. This is the Tibetan Plateau along here. And these are the biggest mountains in the world, and they're still actively being built. So they are getting pushed up, but they're eroding probably as fast as they are getting pushed up. So this is probably as high as a mountain range can get. Since there's no seafloor ages to discuss, and there are other examples of this, most usually right over here, where Arabia is pushing into Eurasia as well, and there's a lot of mountains along this area right here. So those are a couple of examples of continent versus continent collisions. And